Hello, in this video we are going to do a demonstration of variable selection using the R programming language. And again, this class is not a programming class, but it can be very educational and informative to actually see variable selection in action. So I'm going to open up R, and so this is the R programming environment, and in a previous video I showed how to install R and how to get it up and running. So this is just the R environment. Now I've written a program, and this is a variation of one of the earlier programs that I've already shown you. And what we're going to do here is I'm just going to take and read in the Steam data set that we've been using up until now. And this code here will read it in. See, I have a data file called steamdata09.txt. So I've got that guy. And this is where it's located. I'm going to read it in right here, and then I'm going to print the first 6 guys on the list and the last 6 guys. So that's what this code's going to do. And again, just refer you to the previous video on R for you to understand this. So anyway, I just read in this guy here. This is where the file is located. This is the name of the file. I've read it in. It's a CSV, comma separated variable file, and I printed off the first 6 records right here and the last 6 records. So that's the data's read in, but what I want to do now is build some models and do some variable selecting. So the first thing I'm going to do is I'm going to build a predictive model, as we've already done earlier. And this is a linear model. And I'm going to predict Y, which is, remember, the amount of pounds of steam, using these 9 variables. So I've built this model, and if we look at the model, we summarize it. You can see these are the coefficients in front of the variables, and these are the statistically significant ones. And so this is our model. So now what I want to do now is show you how variable selection can be used with this model. So now that I have the model, there is a command in R called step, and that's right here. And what I do is I give my model to R, which we call it m.all, which means this is my model, and I called it m.all, meaning the model with all the variables. And I'm going to give him that model. And I'm going to do a backwards selection. So he's going to start throwing stuff away. And then I have to also give him this command here, scope. And what this does here, it's got a little tilde and then all of the variables. Basically, it's this guy right here. And what scope does is it includes all of the variables that are in the model and all of the variables that you want to consider adding or deleting from the model. When you're using a backwards selection, you don't have to put the scope. It's just going to start throwing stuff away. But it doesn't hurt anything, and I like to do this for consistency. So what I'm going to do is I'm just going to do a backwards selection, and I'm going to start throwing away stuff here until the model stops getting good. So let's do that right now. So he just did that. So we started off with this guy right here. So the AIC, remember we talked about that in the metrics of how to see if your model's any good. We started off with this guy right here, and the AIC value is minus 20.9. And so the R programming language looked at all of the options here. So he says, well, if I throw away the x2 variable, my AIC improves to minus 22.5. If I throw away x4, this is the AIC. So he basically rank orders them, and none, meaning don't do anything, has a value of minus 20. And that means that if I throw away anybody else, it starts getting worse. So what R will do is he's going to throw away the x2 because that's the one that improves things the most. So now the guy to beat is this guy right here. See, we don't have x2 in there anymore. Now he looks and he says, well, wait a minute, if I throw away x6, then what will happen is my my AIC will improve from minus 22 to minus 23. And then this is what happens when I do the rest. So he says, well, I'm going to throw away x6 now. So now you see I don't have x2 or x6 in the model. Now he looks in x4. If I throw this guy away, he'll improve the model. If I do nothing, nothing is the second place. So he's going to say, well, I'm going to throw away x4. So now we have 1, 3, 5, 7, 8, and 9. Then he says, well, if I do nothing, my AIC will be minus 24. But if I throw away anybody else, it starts getting worse. So he stops. So this is how that worked. So let's, just for fun, let's open up this Excel spreadsheet that I have and take a look at the variables selected using backward selection. We see that the AIC value was minus 24.66, and he liked to use x1, and he liked x3, and he liked x5, and he did not like x6, but he liked x7, he liked x8, whoops, and he liked x9. So those are the variables that made it into the model. So let's take a look at some of the other things. So let's try doing a backwards stepwise selection. So now what I'm going to do is I'm going to use the same model that I used before, and now I'm going to change the direction to both, and that means stepwise. And again, I include all of the variables that are either in the model or I want to consider adding or deleting from the model. In this case, it's everybody, so we're just going to put all the variables, just copy this guy here and put him right here for the scope. So let's do that. Let's see what backwards selection gives us. So now the backwards selection, he starts by, it starts with the same thing. He throws away x2. And then he says, well, I can throw away x6, I can throw away x4 if I do nothing. Hey, if I bring x2 back into the model, that becomes third place, and then these are the rest of these guys. So at this point, he's going to say, well, I'm going to throw away x6, so he throws him away. Now he says, I'm going to throw away x4, I can bring x6 back, I can bring x2 back, because this is a stepwise, because I can bring guys out and bring them on back. You're never dead. It's like a zombie. Once you're out of the model, you can come back in, and you're never safe. So, this is kind of like your position is never secure with stepwise. So, he decides x4, so he throws him away. Now he says, okay, if I do nothing, or I bring these three guys back, nothing is my champion at this point. x4, x6, and x2, I can bring any of them back, and it will make my model worse, or I can throw away any of these guys and it will make the model worse. So he's going to stop. So at this point, my backwards selection is going to give me the exact same answer as the previous guy. So I'll just copy and paste him. So sometimes these guys come up with the same answers. Okay, there's no guarantee that's going to be even a different answer. Let me make this center here. Make it look nice and pretty. As long as we're going to do it, let's go big or go home. Let's make these guys look pretty too. Okay, so let's take a look at forward selection. What happens if I do that? Well, I'm going to start off with M1. So this is going to be a model that has no variables. It's just going to be a model with an average. So let's just do that. I'll show you what that one looks like just for fun. So you see if I do a model M1 here, and then I summarize it, you can see that it doesn't have any variables. All it has was an intercept or an average, which means that it's simply going to predict that everybody uses 9.4 pounds of steam every month. So that's what the model is. So now we're going to do a forward selection. So what we're going to do is we're going to do a stepwise selection as before. We're going to give them this model right here, and this model doesn't have anything in it but an average value. And the direction is forward, so we're going to start adding stuff into the model. And these are all the variables we want to consider. Now these are either the variables that are currently in the model or the variables I want to consider adding to the model. So if I took x9 out right here, then the R programming language would not even consider adding X9. But let's just see what the forward selection gives us. Let's just do that one. So there you have it. So he starts off with doing nothing, and the AIC value is 25.43. And then he looks at adding X7, and that improves the AIC to -3. And then he looks at adding a 6. And so this is what happens if he adds any variables. Apparently X4 is worse than doing nothing. So if I do nothing, then my AIC stays the same, but if I add X4, my model gets worse. So probably X4 is not predictive. But anyways, at this point we see that X7 is the best. So we add X7 to the model, and my AIC improves to -3. Then the R programming language says, hey, if we add X1, my AIC improves even better to -19. And if I add X5, it improves to -21.49. Then take a look at this. When I add X5, suddenly adding X4 and X9 become very appealing. They weren't that appealing before, but now when this guy's in the model, suddenly adding these guys adds something. So now he adds X4 to the model, and take a look. Suddenly doing nothing is the best, and then it gets worse from there. So we stop. So X7, X1, so our AIC value here for the forward is -22.54, and we seem to like X7. That's a real good variable. Let's take a look at X1. He liked that guy. X5 was good, and X4 was good. So that's what happens if we do forward. Now let's do a forward stepwise selection. Come down here, and I'm going to put M1 in there again, and I'm going to go in either direction, throwing stuff in and taking it out, and these are all the variables that either are in the model or I want to consider putting in the model. So let's see what happens this way. So he starts off with nothing, and just as before, X7 improves my AIC from 25 to -3. It's lower, so lower is better, so X7. Then we see that this is what happens when I add any of the variables. X1 is obviously the one that improves things the most, and it even considers putting X7 back in, or taking it out of the model, but that's not good, so that's the worst thing. So he now adds X1 into the model. Okay, great. And then now he's going to add X5. So X7, X1, X5. I think this is just as had happened before. But now he takes a look and he says, well, what happens if I do X4 and X9? So again, he does that. So at this point, we have the same thing that we had with the forward selection. But now he says, wait a minute. I'm allowed to take stuff out of the model. So now he says, well, if I take X1 out of the model, you know, I've now got all these guys in. If I take X1 out, it improves my AIC. So this guy was helping us, but now that I threw this guy into the model, suddenly this guy here, this X1, becomes, probably these guys are correlated with one another. That's probably what's going on. So if I put X4 in, or if I take X1 out, suddenly my AIC value improves to -22.625. And then at that point, doing nothing is the best thing. So we stop there. So we've got 3 variables in the model. So let's take a look at that. And we have a -22.63. And what is the variables that we like? We like X7 again. We like X5. And we like X4. Now, you don't have to just start with everybody or nobody. We could start with something else. Like for demonstration purposes, let's start with 2, 4, 6, and 8. So just the even guys. So let's build a model with that. And if I do that, I build the model. And so this will be the starting point. And let's come over here. And let's do a stepwise selection now. So what we're going to do is we're going to go in both directions, take stuff out, put stuff in, and my scope variable has to have everybody who's in the model, 2, 4, 6, and 8, and anybody I want to consider adding or deleting from the model. And in this case, I want to include everybody. But I could, if I didn't want to put X9 in there, I could take him out, no problem. But I have to have everybody who's in the model plus everybody that I want to consider, with my forward selection. Anybody I want to consider or is currently in the model. So let's put this guy in here right now and see what we get. I don't know what the answer is here, but let's see. Okay, so we've already seen how this process goes, but he starts with this, and he examines adding this guy, taking out X8 and adding this, but this is the best guy, so we've now thrown X7 into the mix. Now he looks at adding some guys and deleting some guys, and this is doing nothing. So he adds X5 to it, and then he says, well, hey, maybe if I throw away X2, and things got better still. Now he's going to throw away X8, and things got better. And then he decides to throw away X6, and he converged to X4, X7, X5. So let's take a look at that. And it's the same thing as before. It's the same as this guy right here. And let's see if we do a forward selection. In other words, we're going to use all of the even guys, but we're going to consider adding some odd ones as well. So let's do a forward selection and see what we get. So at this point, he just says, well, I'm going to add X7 here. And the AIC improves from 4 to minus 13. Then he says, I'm going to add 5, and it goes to minus 18. Then he adds 3 to the mix, and it goes to minus 19. Then he adds 9 to the mix, and we get minus 20. And then he adds 1 to the mix. And at this point, it looks like he's got everybody in there. So let's see. Let's bring up our Excel spreadsheet, and we have an AIC of minus 20.9. And who's all in there? Well, X2 is in there. And we know X2, X4, X6, and X8 are in there. And X7 is in there. X5 is in there. X3 is in there. X9 is in here. And X1 is in here. So, yeah, this one didn't do all that well. Let's get rid of him. We don't need him. So, at this point, you can look at maybe if you decide what model you ultimately want to use, you could say, well, let's go with the best AIC, and that would be probably one of these two since they're identical models. Or perhaps you could say, I don't know, this I might want to go with one of these guys because they seem to have fewer variables. This guy has 1, 2, 3, 4, 5, 6 variables. This guy here has 1, 2, 3, 4, and this one has 3 variables. I don't know. So at this point, how I would be doing this is I would be evaluating the model from choosing between any of these guys. You might even go so far as to say something like, well, we notice that X5 is used every single time, and so is X7. So I might even just say, let's try a model with just those two guys. So let's, just for fun, let's do a model that we'll call popular model. I don't know. So let's just say a popular model. And this is just using the ones that are popular, the variables that seem to make it all the time. So you might want to even do a model with X5 and X7. And let's see here. And there we go. Let's summarize that guy. And there it is. It's these are the coefficients. I'm looking here for, it doesn't seem to give me the AIC value, but I think we could get it up here somehow, because I think there was a model with X5 and X7 in there as one of my forward selections. Well, no, it usually adds 1 first. So let's do this. Let's just for fun. I can't seem to, off the top of my head, I don't know how to get the AIC value, but we're going to just play a little game here of doing a stepwise selection here. And seeing what happens if we decide to add X1. So we know our model has these two guys in it, and also we're going to consider adding him. So let's just do this one real quick, and then we'll call it a night. Okay, so there you have it. We have the current model has an AIC of -17, and if I add 1 to the mix, it goes to -21.49. So it seems to be a major increase. So I might even go so far, if it were me, to maybe do something like this. It seems to be maybe X1, X5, X7, something like that. But there's a lot of judgment calls in doing this. But this is how the variable selection works. And of course, we can use other techniques, which we'll use later in the quarter, maybe decision trees or something like that. But I just wanted to give you a flavor for how this is done. And this is how it would be done using the R programming language.